Hello and welcome again to our lesson recording. So today we're going to talk about the second law of motion, which we call the law of acceleration. Before we go to the statement of the law, let us have first a review of what the first law is all about. If you remember that the statement of the first law of motion, which is the law of inertia, talks about if forces are balanced. If forces are balanced, then objects will stay at rest. And the other objects that are in motion will stay in motion. But until an unbalanced force acts on them, they will going to change their motion. They will going to change their behavior. The law of acceleration points out and explaining those events wherein forces that acts on the object are unbalanced and not balanced. So let us examine what the law of acceleration tells us. This law of acceleration tells us that the acceleration of an object is directly proportional to the net force and inversely proportional to the mass of the object. To further explain the law of acceleration, let us divide the two relationships that can be found on the statement. The first is the acceleration of the object is directly proportional to the net force. We all know that the acceleration of the object is only present when the object is changing its velocity. If not, then the acceleration is equal to zero. But in the law of acceleration, it also points out that whenever the amount of acceleration, it will be equal to the amount of force. In other words, an object cannot accelerate without changing the force applied to the object. So, the bigger the force applied, the greater is its acceleration. The smaller the force applied, the object will also decelerate. The second relationship is about the acceleration is inversely proportional to the mass of the object. This means that the amount of acceleration is the reverse output of the object's mass. If the object is having a bigger mass, then the object's acceleration will be lesser. If the object has a massive mass, then its acceleration will be smaller also, which is also works in vice versa. If the object has a smaller mass, its acceleration will greatly increase. Unlike inertia, the three concepts of the second law are inseparable, which means they're always bounded to explain how objects behave under unbalanced forces. So, how do we how about the direction of acceleration? Take note that acceleration and force are both vector quantities. And vector quantities measures magnitude, at the same time, direction. If acceleration is directly proportional to the force, it means that the direction of the motion will also point out to the direction of the force applied to the object. Whatever direction of the net force is used, the direction of the acceleration will also follow. Let us have some connection with our law of acceleration. In concept of the law of inertia, if there are forces that are balanced, then this will be the conditions, or this will be the statements. Object will remain at rest, and objects in motion will remain moving. But in acceleration, if forces are unbalanced, then there is an acceleration. And their acceleration will not equal to 0 as long as the forces are unbalanced. So, there are two things that might happen if there is an acceleration. One, this acceleration will depend directly upon the net force. And two, this acceleration will also depend upon the object's mass. So, the amount of acceleration is dependent on two things. First, net force. Second, the mass of the object. In which the second law of motion forms an equation, which is A is equal to F net divided by M. Or, to derive the formula, we can have a more easier way to follow, and that is F net is equal to M multiplied by A, where the F sub net is the net force, M is the mass, and A stands for acceleration. The unit of force is equal to the unit of mass multiplied by the unit of acceleration. By substituting the standard metric units of force, mass, and acceleration into the above equation, then the following units can be written. 1 Newton is equal to 1 kilogram times meter per second squared. So, the definition of this SI unit, or in the metric system of force, is defined as 1 Newton is equal to the amount of force required to give 1 kilogram an acceleration of 1 meter per second squared. This is based on the standard of the metric system. You see, the formula that we use in acceleration is not just an ordinary formula, but also what they're trying to have a conversion within their units. Let's try to solve a real-life problem regarding the law of acceleration. Determine the accelerations that result when the same 12 Newton net force is applied to a 3 kilogram object and to another 6 kilogram object. Our answer? First off, we are going to identify the given. And the given are the net force is equal to 12 newtons. Since then that we are going to solve for two accelerations of different objects, therefore we should have two masses also. The mass of the object, the first object or object A is 3 kilograms, while the mass of the second object is 6 kilograms. Our solution for object A is that we are going to find its acceleration. In order to do that, we will use the formula for the law of acceleration, which is acceleration is equal to the net force divided by mass. Substitute the values to our symbols or the formula. A is equal to 12 newtons for the force divided by 3 kilograms for the mass of the first object. Dividing force by mass, 12 divided by 3, it will give us 4. And the unit is meter per second squared. For object B, it is the same thing. But instead of 3, we change the real mass of the second object, which is 6 kilograms. So 12 divided by 6 will give us 2. And the acceleration is 2 meters per second squared. So what are the things that we learn from this very simple question? First off, that the force is directly proportional to the acceleration of the object. But also, the acceleration is dependent not only with the force, but with the mass of the object. Let us try to notice that the different masses of the objects also results with a different acceleration. A 3 kilogram object using a constant value of the force give us 4 meter per second squared acceleration. And a 6 kilogram object give us an acceleration of 2 meters per second. So what does it mean, or what this problem implies to us? It only suggests and evaluated or approved that mass is inversely proportional to acceleration. The bigger the mass, the lesser is its acceleration, and vice versa. Now you know how to solve for problems relating the law of acceleration. Then, let us find out with our next meeting how to solve for other problems relating to the law of acceleration. Goodbye to everyone.